Okay, welcome to Learn Robotics and AI. And in today's video, I'll be sharing with you an experience of non-programmer, and she wanted to make a transition to machine learning specifically. So for the sake of confidentiality, I've changed the name and we'll call her Avni Malik in this session. So she is a freelancer. She did her bachelor's in electronics. She is an Indian and located in India. She has basic skills in Python and C++, but only based on some hobby projects and not based on any prior work experience. So she wants to pursue a master's in robotics, AI, or machine learning in Germany and needs relevant work experience before applying for masters. And she's willing to gain programming experience by creating actual projects and has 10 to 15 hours available for her every single week. She's interested in robotics, machine learning, artificial intelligence, and her primary priority is robotics, and then after that machine learning or AI, and if not, then she's also open to do a master's in general software engineering, and she also expressed her interest in speech recognition or NLP in general. So the only experience that she had was she did a semi-technical internship at a startup, and her BTech project was basically a small Python-based project, and she built some games using C, C++ as hobby projects. Some specific queries that she had were, what are the job opportunities in Germany? So these are some of the queries that I receive a lot also via LinkedIn and also by means of these calls that I'm doing. How should one effectively apply to startups? How to effectively perform skill assessment, self-assessment of basic programming and problem-solving skills. So she watched my video on the complete roadmap to start learning robotics and AI, and she actually was performing all of these steps, and she was stuck a bit at how to perform self-assessment of some basic programming and problem-solving skills. So I'll address these as part of this video. And how do you gauge the difficulty level of a project? How does one choose a project? How does one decide, hey, this project is easy enough for me, or this project is maybe too difficult and I have to take it at a later stage? How to decide which domains to choose from? So all of these questions. And so the aspiration that she had was, I want to build a strong profile so that I can apply for a master's program in robotics and AI. And for that, she required to build a strong portfolio of projects. But this is just an aspiration, just a wish, and we have to break it down. So I helped her break it down into goals and systems. So considering the learning framework that I proposed in my video titled The Complete Robotics Roadmap, we will divide the learning plan into four specific phases. One is building the foundation, the second is curiosity driven exploration, the third phase is domain driven exploration, and the fourth is progressive mastery. So the yearly goals can be divided into several specific sub goals based on each of these phases. So for phase number one, which is building the foundation, I propose that she does a ROS crash course just so that she can explore if she really wants to go into the robotics software engineering route, and also a TensorFlow crash course, because whether she chooses general machine learning, computer vision, or natural language processing, TensorFlow or PyTorch would be beneficial to know. And TensorFlow is slightly easier to begin with, and that's why TensorFlow crash course is a good way to build a foundation in machine learning, and specifically machine learning tools. And Git and Ubuntu are obviously something that every software engineer should know, regardless of whether you choose to go in the robotics domain or machine learning domain or even web development and so on. So Git is something that everyone needs to be familiar with, and you can simply watch a 1 to 2 hour long crash course and do some hands-on practice with that, and that's it. That's all you need to know to be uh, good with Git. It doesn't take much. And Ubuntu, likewise, getting some familiarity with shell scripting, command lines, and how does Ubuntu work. Just being familiar with the Ubuntu operating system in general is essential to build the foundation. So skill assessment can be skipped as she already had some basic programming and engineering background, although her programming background was not advanced, and she basically did some side projects as part of her college, but she did her bachelor's in electronics, and so she has some engineering background and a certain level of programming background. So we can skip the self assessment part and we can focus directly on building the foundation for robotics and artificial intelligence. So this would be the first goal, or the first set of goals, which would be to do these four crash courses, and the second set of goals come under the category of curiosity driven exploration. And I propose that she does a mini project in speech recognition and natural language processing based on her interest. So she expressed that she was very interested in natural language processing and speech recognition, and the goal of curiosity driven exploration is to allow her to really follow her interests and really decide whether or not she really likes these fields. So these projects need not be uh, very big, or these should not consume too much time, several months and so on. A maximum of 4 weeks and a minimum of 2 weeks should be more than enough to get a sense of whether it is something that is interesting or not. And then it is also extremely important to explore some other domains that she has no idea about, such as robotics, mobile robotics in general, robotic software development, and the other one would be computer vision using machine learning. So these are three specific domains that she has to explore, or four specific domains: natural language processing, speech recognition, robotic software engineering, and computer vision. And after that, the final set of goals is really choosing a niche based on these four domains and actually completing one major project in the chosen niche. So, of course, multiple projects can be done, but taking the time stamps into account and the other uh, preliminary projects already would consume a lot of time. And so it makes sense that 1/4 of the year is dedicated to one major project, which would make a strong portfolio in allowing her to get a master's opportunity. So the first quarter is dedicated to learning, building the foundation by doing these crash courses. The second quarter is exploring based on her own interests, which is curiosity-driven exploration. So a project in speech recognition and natural language processing. The third quarter consists of defining a niche and doing two mini projects based on these two mini projects, and also two mini projects based on her curiosity. She would be defining her niche, and then the last one would be to complete one major project in the chosen niche. So these are the goals, and then the goals can further be broken down into monthly goals. So for the first quarter, the first month can be dedicated just to get familiar with Git and Ubuntu, and the second month can be spent on becoming slightly familiar with TensorFlow, and the third month can be spent in doing a ROS crash course. And month number 4 could be spent doing a mini project in speech recognition. It could be done within a span of 2 weeks, even. So I've allowed her to spend one full month to explore and maybe take a break after completion of every single project. And then month 5 is to complete a natural language processing project. Month 6 is a buffer month in case there's some trouble in understanding some of the fundamental concepts, or trouble in getting familiar with TensorFlow, ROS, Git, and so on, or if she wants to explore some of the topics in slightly more detail. So this would be buffer month, month number 6. So in 6 months, basically a strong foundation in at least one domain has already been built. You can see that two mini projects are completed, and also fundamentals in using Git, Ubuntu, TensorFlow, and ROS has been made. And the third quarter, month number 7, would be dedicated to robotics software engineering project. And after that, the next month is going to be spent in doing a computer vision project. And the last month can be spent in defining your niche. And again, the last month can again serve as a buffer month, because maybe the robotics project would take slightly more time than anticipated, or the computer vision project, because these are also not directly in the domain of the client. So you can uh, so 1 month can be dedicated in really defining a niche and also finishing any incomplete projects along the way. And the last quarter is it's can be spent doing a 3 month project on within the chosen niche. And these goals can simply be broken down into 4 sub goals, one for each week, and then these can be broken down into daily goals. So I recommend that one spends a minimum of 1 hour on weekdays and 4 hours on the weekends. So a minimum of 13-hour week. More can be spent as well, and the more time that you can allocate, the quicker you can make a transition to machine learning, NLP, or robotics. And here's a list of some of the robotics projects that one can choose from. Obstacle avoidance in a simulated environment using ROS and C++. So this is a beginner friendly project that one can do. And then one could also do a robot arm control using move it package and ROS and C++. And so the client had some experience in C and C++ by building some hobby projects. So that's why, and also for robotic software engineer, generally C++ is valued more. Of course, Python is also used at a lot of places, but since the client has some experience in C++, she could explore whether she really likes working with C++ or not. And some major projects could be autonomous drone navigation and object recognition, multi-robot communication and collaboration. These are projects of slightly longer duration, such as 3 months, and require some more effort. So if she chooses her domain or her niche as robotic software engineering, then one of these projects could be chosen. So these projects require ROS, Gazebo, and C++ primarily, but also OpenCV or Move It, depending on the kind of project that it is. And then for computer vision, face detection and recognition using TensorFlow and Python is a basic project for which there's also a lot of tutorials that one can easily find online. So this is something that one can try to just analyze if they really find this domain interesting or not. And then image stitching and panorama generation that uses feature detection, feature matching, feature extraction, homography estimation, and things like that, and primarily uses OpenCV. So all of these projects can serve the purpose of really exploring the domain. And once one chooses computer vision as their domain of interest, then they can do slightly bigger projects such as real-time object tracking for autonomous vehicles, and that can require YOLO as an object detection model, or some other object tracking models can be used. And TensorFlow, OpenCV, and Python. So in all of these projects, I just recommend sticking with TensorFlow and Python. And there can be a unit based semantic segmentation project, which is also used quite a lot. Unit is a very popular project. Unit and Mascar CNN are popular segmentation models that are used. So this is also going to give one the clarity whether or not these kinds of projects are interesting or not. So I'm not reading the descriptions of these projects. If you're curious about some of these projects, you can pause the video and read the description, or you can Google and find some tutorials and really try to make a sense of if you are of whether or not you're interested in these projects, and really try to build it by yourself if that sounds interesting to you. And NLP engineers, uh, also some projects that use TensorFlow could be semantic analysis on Twitter data using TensorFlow and Python, one of the most common NLP projects that one could do. Then there's text generation using recurrent neural networks or LSTMs. And this is another basic project to just give one the idea of whether or not this is something that you really enjoy doing. Then slightly bigger projects, question answering system, develop a question answering system using BERT model trained on the squad data set. So very specifically described what are the things that you would be doing as part of this project. Given a passage and a question, the model should accurately locate and provide the answers from the package. So a question answering system using TensorFlow and a transformers library, and primarily using Python. Then another project could be to build a sequence to sequence model using an attention mechanism, for instance, for language translation. And the goal might be to train a model to translate from English to French or from one language to another language. And this can also be done using sequence to sequence with attention algorithms and implementing in TensorFlow and Python. Some slightly bigger projects or mini projects in the speech software engineering for speech recognition domain could be speech emotion recognition. So implementation of a speech emotion recognition system that classifies spoken sentences into different emotions using machine learning techniques. So scikit-learn is a package that one can use for this, or keyword spotting with deep learning using convolutional neural network or recurrent neural network. So these are two specific projects, and for keyword spotting, essentially one would create a keyword spotting system that can identify some phrases in the spoken audio. So really identifying some specific keywords using Liprosa, TensorFlow, and Python. So some major projects in the speech recognition domain could be automatic speech recognition system, which requires training an end-to-end automatic speech recognition model that can listen, attend, and spell on a large audio data set with corresponding transcriptions. And again, Librosa and TensorFlow are generally used for this. For speaker identification and verification, one could develop such a system using speaker embeddings extracted from audio data and build a model that can identify known speakers and verify if a sample matches the specific features. So I'm not going to read through the entire text. So again, you can pause the video and really try to make sense of these projects and uh, just spend some time researching more on these topics. You'll definitely be able to find tutorials on this, or Medium articles, or YouTube videos explaining most or all of these projects even, and that should give you a sense of what kind of projects you're interested in. So now coming to the specific questions, what are the job opportunities in Germany? This is something that I've answered in some of my previous sessions, and here are some robotics companies: Agile Robots, Ansa Robotics, Artisans, Magazino, Micropsy, Neura Robotics, Bosch. Some bigger companies include Volkswagen, Daimler, Fanuc, Deutschland, and more. So a lot of different companies can be found easily on LinkedIn. So I'm not specifically giving a list of companies in the NLP or computer vision domain. One could easily find a list of companies that one is interested in, and that would also be very specific to the person. So if you're someone who is looking for startups, you'll probably spend some time looking for startups that are doing the kind of things that you're interested in. If you're looking only for bigger companies, then you can really identify those companies also just by looking on LinkedIn, and also just um, making an analysis from the official websites of these companies. So these are some things that one can easily look. In general, look for. One specific thing maybe I can mention here is that there are more robotic startups in the south of Germany in cities such as Munich and Stuttgart, um, whereas a general machine learning and computer vision startups are maybe more prominent in Berlin, Aachen, Cologne, Bremen, Karlsruhe, but also in Munich and Stuttgart. So in general, in Munich, there's a lot of opportunities in all of these domains. And talking about the salary, as a beginner, one would expect 55,000 to 65,000. It can be more if you can really negotiate for it, if you have the right skills, and sometimes startups can pay you more as well. But in general, that would be the range, and you can expect to receive some 2,500 to 3,300 euros after tax deduction. So how do you apply to startups? Making a list of companies in your niche from LinkedIn and portals, and then browse the official website of the companies for relevant jobs and make a list of the skills that are the most required. So if you are someone who wants to go in the robotic software engineer route, then maybe ROS and C++ are more relevant to you. And you can look for the companies that offer this kind of role, and you can really try to build projects that use these skills so that you can demonstrate it to the employer that, hey, I have built two or three really nice projects that use ROS, and that would be a strong portfolio. You can use that portfolio to apply to these companies. And one special tip is that you can also do an unsolicited application to a lot of companies. If there are no job openings specific to your interest, a lot of startups are actually open to hire candidates just based on their motivation, and if they have a certain skill set, they would even open up new positions if you are the right candidate. How do you effectively perform self-assessment of basic programming and problem solving skills? In general, one could take up competitive coding challenges on Kaggle, Lead Code, and HackerRank, and really try to make sense, maybe just intuitively, of whether your programming skills are good enough, or do you need some more practice? Is your code clean enough or not? You can also approach people who are already experienced in programming, and you can make your own projects on GitHub and share those GitHub repositories with someone you already know, and they could give you a feedback. And by means of these methods, you can essentially get an intuitive sense of how good or bad your programming skills are and how much you need to improve. But essentially, if you just stick with building projects, you would eventually improve your skills. Just by the very nature of it, you would start realizing that, hey, this is something that I'm doing inefficiently, and I could maybe write functions in this manner, or I could organize my codes in proper code in proper modules and things like that. So look at the code bases of existing repositories and also compare it with yours, and that would probably give you good idea of your own skills. And you can even copy the programming styles of some of the GitHub repositories. There's a lot of open source projects on GitHub by the top companies, even Google, Facebook, uh, Meta, and a lot of other companies, and you can easily try to emulate their coding style and try to learn from that. So, how do you gauge the difficulty level of a project? This is also a question that is perhaps asked very commonly. And this is also something that only you can determine for yourself. And this is something that can be intuitively determined by whether or not you are enjoying the process of programming. If a project is maybe if you're feeling overwhelmed, then maybe the project is too hard for you, and maybe you need to take up a slightly easier project. So if a project is hard, if the challenge exceeds your skill set and you feel overwhelmed, so this is not something that you would like to do, because you want to also enjoy the process. You should try to be in the flow state, which is a perfect harmonious state where your skill level and the challenge of the task are in alignment with one another. And if you're getting bored while you're programming, this is probably because the project that you've chosen is maybe too easy and your skills are slightly better than in the project that you've chosen. So you can take up a slightly more difficult project, and of course it can be a challenge to find that kind of project. But there's lists of dozens of projects that are online on several websites. You can easily spend some time searching and compiling a list of your own projects that you find interesting. So it's super simple to just Google search and find the projects that you find interesting. So spend some time and take the initiative. And you can balance your skill level and the project challenge by taking up projects of progressively increasing difficulty level. So once you have built a certain project, then of course you want to level up and take up slightly difficult projects after each project. How do you decide which domains to choose from? Well, there are two modes. One is curiosity driven exploration. This is just simply based on your interest. So you say, hey, I'm interested in NLP and speech recognition, and you would just explore that. And another one would be domain driven exploration. So explore domains about which you have no idea, and that could be totally different, such as automated task planning, for instance, or computer vision, or even in the mechanical domain, maybe kinematics and dynamics and so on. So you can explore. You should also be spending some time exploring domains about which you have no clue, or about which you do not know much, and that would maybe allow you to explore a domain that you might like in the future. And maybe there's a domain that you would enjoy more, and if you do not try it, you would never really find that out for yourself. As a bonus, there are some ROS resources that one can try. I've talked about these in a lot of my videos, so I'll not repeat it. And there's another video on my channel titled A Complete List of ROS2 Resources, or something like that, the most comprehensive list of ROS2 resources. So you can go ahead and watch that video that consists of all the ROS2 resources you need to know. And essentially, there's an abundance of resources online, so you do not even need to watch that video, but that video just summarizes all of these resources in a structured manner. So maybe you can have a look at that and find the resource that you find the most beneficial, and really then just stick with one resource or two resources and start building projects as soon as possible. So that is how you can make progress on your robotics, machine learning, natural language processing, or computer vision journey. So, to gain clarity on selecting a career direction, you should always ask, which projects do I enjoy doing, and which tools or libraries do I like working with. So, these are some things that one should consider. And that is it. Lastly, I'd like to mention that building a personalized curriculum is something that you can also do for by yourself, by just watching my video or titled The Complete Robotics Roadmap, and watching The Ultimate Robotics Career Guide. Maybe these two videos would give you enough information to just sit down for 2 to 3 days and really prepare a plan for yourself. And the next part is then really sticking with the plan, and then you can watch the video titled The Complete Productivity Guide for Robotics. And if you still struggle with making a plan, you can hop on to a call with me, and I'll help you create a personalized roadmap like I have done for the clients that I showed you. So, good luck to you, and hope you keep on making progress in your learning journey.